What is a periodic function? In this video, we're going to be working through some of the first examples within our periodic function activity to try and answer that question and gain a better understanding of what makes a function periodic. So let's start with the textbook definition. A periodic function is a function whose output values repeat at regular intervals or cycles. So after a certain amount, the function's gonna look exactly like it did before. It's gonna repeat what it just did. And you can sort of think about that algebraically with this notion of, okay, so our function has some output, we call it f of x, and then p units later, so f of x plus p, the function's gonna hit the exact same value. And then, f of x plus p will be back at the exact same value again, where p is some positive constant value. Now, p gets the name, and that name is really important. It's our sort of first key feature that makes a periodic function periodic, and it's the period. So we call p the period of the function. And basically, the period is the horizontal distance a function travels before it begins the cycle again. It repeats itself. Now, horizontal distance might be a weird sort of way to think about it, but I'm struggling in my mind to think about how to describe what it is. It's basically how many input values. So you could also think about this like as the change in input until, it repeats itself, until we see, the outputs, the output repeats, so the output hits the same value again. So we have this is a key thing to keep in mind. Now, we can look at this in sort of a little closer context down here on this very first graphical example. Now, I can sort of see how the function repeats, and I like to start with sort of the lowest sort of part of the graph. And if you notice, our function sort of takes 3 units and it goes all the way to its max value, and then we go sort of 3 units and it hits 0, and then we're going to, with over 1x unit, going to go all the way down to the bottom and sort of back to where I began. Because if you notice, oops, and I want to switch colors, it starts the cycle again. We go up for 3 units till we hit the max, down for 3 units till we hit 0, down all the way back to that starting sort of bottom value. And if I notice here, I could count 1, 2, 3, 4, 5, 6, 7. So what we would say is this function has a period of 7 units because every 7 units it repeats itself. And I could double check that over here. Notice 1, 2, 3, 4, 5, 6, 7. And using this notion that every 7 units my function repeats, I can create more parts of this graph. I could go, okay, well, I know from here we're going to be going up for 3 units until, oops, and I didn't go up steep enough, so it helps if I graph it correctly. We're going to go up for 3 units till we hit that max value. Then we're going to come down for 3 units till we hit 0, and then over 1 unit we're going to go all the way back to the bottom at 16 here, so f of 16 will be back at that minimum value, and we've gone another 7 units. Or we could work backwards, and we could think, okay, well, so this would take us back to the 0, then we're sort of going to go 3 over till we hit the max, and then we're sort of going to take 3 over till we're back at the min, and this would have worked backwards 7 units. But notice this pattern is going to keep going until the domain ends. If you're not given an unrestricted domain, it would continue on until infinity. And it doesn't just have to be the minimum or the maximum values. We could just pick a random point along the way. And sort of that's what I was showing off here in this sort of second sentence here in this activity. So we know that f of 10, so f of 10 is negative 2 right here. Well, guess what? F of 3 is also negative 2 down over here. And if I look, these points, 10 minus 3, are exactly 7 units apart. Now you might be going, well, we hit negative 2 at another part of the function. Yes, we do. But that piece of the function is it's like a decreasing line. And so we wouldn't that point there where it's at -2 wouldn't be, one period later because the pattern hasn't quite started to repeat itself again. But I can use this to find other points on my function because every 7 units, I'm going to be back here at -2. So I could say, okay, well, if I added 7 to 10 again, plus 7, I'm going to be back at, -2. And so I could say f of 10 plus 7, which is f of 17, we should be back at -2. It's not shown on the graph, but knowing that the pattern repeats itself. And we could use this to work backwards too. We don't have to just add the period, we could subtract the period. So if we subtracted 7 from 3 there, that's where we ended up with f of -4. And if we subtracted it again, we'd end up at f of -11. Well, what if I want to know what the next point on this pattern would be? Well, f of -11, and I want to go back 7 more units, I would end up at f of -18, and again, should be at -2. And so this idea of we have this fixed amount, what we call a period, and I can sort of use that to know when is my pattern going to repeat. Allows us to sort of make some generalizations about what's going to happen within these functions. Now, this doesn't just work graphically. Obviously, our functions have multiple representations, so we could also examine this within a table of values, and that's what we're doing on example B here. So if we notice on example B, we have some inputs and we have outputs, and we're told, that the function has a period here of 4, and we could confirm this. And so what I like to do is sometimes I like to find the minimum value on a table when I'm trying to confirm this. And so just looking quickly at my outputs, I notice 7 here is the minimum. And I'm going to look, okay, when does the table hit the minimum again? And I notice they hit the minimum again down here at 7. And remember, periods are sort of a difference in our domains, a change in our input values. This has increased 4, and that's where that period of 4 comes in. Now, you wouldn't just have to do it from the minimums. You could also use maximum values. And so I might go, okay, well, 27 right here seems to be my max. And so I notice again, I hit 27 down here. And if I look, 2 plus something equals 6, well, 2 plus 4. And so again, 4 is my period. Now I can again use my period to find other points on this function. So if every 4 units, this is going to repeat. So I know if I added 4 to 4, I would be at 8, and we'll be back at 7. And I could do the same thing with that max value. 6 plus 4 is 10, and so I know I'm going to be back at 27. And we can use that to work forwards and backwards, and it sort of gives us a sense of what's going on, and that the fact that this function is periodic. If you don't see that repeating pattern going on, it's not a periodic function.